All right, class, welcome back to the second session of today. Very good afternoon, everyone. Yes, yes, I all. Good afternoon to all of you present in the session. So, next session, continuation of the Nyquist plot, but we are going to talk about the concept of gain and phase margin. That is the concept of relative stability. Okay, why Nyquist plots are important as compared to Raut-Hurwitz. अभी तक हम बात कर रहे थे just about checking the stability from the Nyquist plot by the number of encirclement, and we were commenting whether the system is stable or not. But that could also be done by the Raut-Hurwitz analysis. But the Nyquist plot can be extended to compare the stability of two systems. Okay, if two systems are stable, which of them is more stable and which of them is less stable can be compared easily by the Nyquist plot. So we'll extend the concept, and the measures of stability are known as the gain and the phase margins. Hi, once again, good afternoon, everyone. All right. Yes, very good afternoon, everyone present in the session. So I see slowly and gradually students joining the session. I hope you have had your lunch properly. Today it was a comfortable break that you usually don't get in my class, but yeah, it's almost 2 hours of break today. So I hope you had your lunch properly. So let us start with the case of gain and phase margin, guys. Okay, and first of all, I'll explain you by taking one example, and then we will solve general questions on this. Okay, so yes, let us start on this. GSHS equal to K by S 1 plus ST1, 1 plus ST2. I am taking a type. I am taking a type of GSHS whose polar plots and Nyquist plots have been sketched already. We have done the discussion of this. The polar plot was of this form, and then we took the mirror image and all to complete the Nyquist plot. So already we have spoken about such functions in the Nyquist class number 2, that is yesterday. Okay. Now, if I talk about GSHS equal to K by S 1 plus ST1, 1 plus ST2, what are the poles of this GSHS? The poles of this GSHS are at origin, minus 1 by T1, minus 1 by T2. All the poles, either they are at origin or in the left half plane. None of them is in the right half plane. So the value of P plus is 0. Okay, now applying the Nyquist stability criteria, n is equal to P plus minus Z plus, P plus को 0 put किया. So I get Z plus equal to minus n. Now for stability, what is the Z plus we want? For stability, we want the Z plus equal to 0. That means there should be no encirclement of the point minus 1 comma 0. There should be no encirclement of the point minus 1 comma 0. Stability के लिए what is the point? Minus 1 comma 0 is the point, as we have been seeing in the past classes. So for stability, we want Z plus equal to 0, and so we want the n equal to 0. For this example, we want the n equal to 0. All right. Now, what is the polar and the Nyquist plot of this is already analyzed in the previous classes. I'll just take a copy of that. Yes. If you remember, we have sketched this yesterday. The complete Nyquist plot for GSHS equal to 1 by S1 plus ST1, 1 plus ST2. I've just copied that graph once again. Okay, this was discussed yesterday. I've just copied it once again. All the magnitude. This was the critical frequency. This was the critical frequency. Okay, 1 upon root T1, T2. If you remember the yesterday class, all the calculations will be there in your mind. Okay, 1 upon root T1, T2 was the critical frequency. At the critical frequency, the polar plot was intersecting the negative real axis, and with the magnitude K1, T2, Kt1, T2 divided by T1 plus T2 is this magnitude. This magnitude. The magnitude at the critical frequency, right? Now, why this magnitude at the critical frequency? Which critical frequency? The frequency at which the polar plot, the Nyquist plot intersects the negative x-axis. Actually, critical frequency can be any frequency at which the Nyquist plot cuts the negative, cuts any coordinate axis, But for stability, we are interested about the point minus 1 comma 0. Where is minus 1 comma 0? Where is minus 1 comma 0? It may be inside this inner loop or it may be outside this inner loop. Call this as case number 2 and call this as case number 1. Okay, so this is the case number 1. Okay, minus 1 comma 0 inside matlab the distance of 1. What is the distance of minus 1 comma 0? It is equal to 1. The distance 1 should be less than this distance k t1 t2 divided by t1 plus t2. That is what I have written. Already we have done the stability analysis of this problem. I am just repeating so that I will continue with this problem. Yesterday we have done similar analysis on this question. So when k t1 t2 divided by t1 plus t2 is greater than 1, okay, greater than 1, to see how many encirclements we are able to see. How many encirclements we are able to see? I will again use my pointer. So this is one encirclement, inner loop, clockwise direction. Okay, and then there is also another encirclement by the outer loop. Another encirclement by the outer loop, and that is in which direction? That is also in the clockwise direction. That is also in the clockwise direction. So two encirclement in the clockwise direction. That is why this minus 2 is coming up. Okay, two clockwise encirclements are there, so that is why clockwise ke liye we write minus. So if n is minus 2, z is given by minus n and z is equal to plus 2, meaning that the system is unstable. Okay, and when k t1 t2 divided by t1 plus t2, if this is less than 1, case number 2, just put down here case number 2. In the case number 2, if the minus 1 comma 0 is outside, so see this will be the distance equal to 1. This will be the distance equal to 1, and this distance 1 is greater than the distance k t1 t2 divided by t1 plus t2, or vice versa, k t1 t2 divided by t1 plus t2 is less than 1. Okay, and because the point is outside the plot, what is the number of encirclement is 0, because the point is outside the plot. And if n is equal to 0, from this formula once again I say that z is equal to z plus equal to 0, and now the system is stable. Now the system is stable, right? Now the system is stable. The point is outside the plot. There is no encirclement. There is no encirclement. The system is stable. Okay. Right. The system is stable. So stability, if I talk about now, stability depends upon basically the magnitude of this point, whether the k t1 t2 upon t1 plus t2 it is greater than 1 or less than 1, or it may be equal to 1 also. That also I will introduce very shortly. That will be marginally stable. Okay, so stability depends upon the magnitude at this point, and I am going to call this point as a special name. Let us call this point P. Let us call this point P. Okay, the point at which your polar plot cuts the negative x-axis. Only negative x-axis will be concerned right now. Why only negative x-axis? Because the stability wala point, stability के लिए encirclement किसका देखते हैं? -1, 0. -1, 0 lies where? -1, 0 lies on the negative x-axis. Okay, so that is why now my most important point of concern is the point where the Nyquist plot cuts the negative x-axis. Then only I will be able to see whether there is the encirclement of this or there is no encirclement of this, right? Right. So I'll call this point as P. I will call this point as P. And as specified that the stable case, the case number 2, this distance k t1 t2 divided by t1 plus t2 is less than 1. Matlab point P is coming before -1, 0. System is stable. Okay, this is outside. That means it is outside. The case number 2 which I have just explained. Okay, and if the point P is coming after -1, 0, like this, okay, that means the distance k t1 t2 divided by t1 plus t2 greater than 1. So then there is the encirclement. I have only taken the polar plot in this slide, and then we saw that there will be -2 encirclement, matlab 2 clockwise encirclement, and the system is unstable. Okay, and there may be the case that the polar plot is exactly passing through the point -1, 0. Is exactly passing through the point -1, 0. And the verge of the boundary of stability and instability is known as marginally stable. So the stability of the system is depending on what? The stability of the system is depending upon, look at this important word, it is depending upon the closeness of the point P, closeness of the point P with respect to the point, our important point of encirclement, that is -1, 0. The stability depends upon the closeness of the point P with respect to the point -1, 0. Okay, and I will give this point P a special name here. I will give this point P a special name here. I will be calling point P as a phase crossover point, that is the point at which the Nyquist plot intersects the negative real axis. Okay, and based on the closeness of this point with respect to -1, 0, whether it is before -1, 0, after -1, 0, crossing -1, 0, where is the location of the point P with respect to -1, 0 is going to determine the stability of the system. Is going to determine the stability of the system. Is it clear up to this point? Please comment, then I will step by step introduce some definitions. Here I am just about to introduce the gain margin first, and then I will introduce the phase margin. Yes, comment. Is that clear? The stability depends upon the location of point P. Yes, is this point clear to everyone? Okay, so I have called that point P as the phase crossover point, the important phase crossover point, and the frequency at which I cut the point P. The frequency at which I cut the point P. What is the frequency, guys, here? What is the frequency? Up till now, we were calling it as critical frequency. Up till now, we were calling it as critical frequency, 1 upon root T1, T2. But at this frequency, the Nyquist plot actually cuts the negative x-axis, and the frequency at which you get the point P is known as the phase crossover frequency. The first important definition. It is the frequency at which the Nyquist plot intersects the negative real axis. It is the frequency at which the Nyquist plot intersects the negative real axis. And how will you get this frequency? You are going to intersect the negative real axis, and what is the phase of the negative real axis? -180 or plus 180, whether you go clockwise or anti-clockwise. Plus minus 180 both can be written. Okay, so at this point, the angle Gj omega p, Hj omega p is the phase crossover frequency. The angle Gj omega p, Hj omega p should be equal to 180 or minus 180 degree. So this is the formula that you will apply in the questions also. Given the GSHS, equate the angle to 180 degree, get the frequency. That frequency is known as phase crossover frequency. That frequency is known as the phase crossover frequency, right? Now, furthermore, next concept. This is the phase crossover frequency. Now, look at one more calculation. Yes, exactly. See, omega p is definitely a critical frequency, Shivans, but every critical frequency is not a phase crossover frequency. Okay, because critical frequency is any frequency. Maybe you can cut the other, if I take any other polar plot example, it may cut this coordinate axis, or the negative y-axis. All of them are omega c. But I am talking as omega p. I have written omega p, and this omega p is known as what? The phase crossover frequency, where you only cut the negative x-axis. So there is a difference between the critical frequency and the phase crossover frequency. Guys, mark everyone. There is a difference in the two. Now, suppose that the magnitude at this point, because this is less than 1, this is less than 1. Suppose the magnitude at this point is half. Suppose it is half, well, this distance, suppose it is half. Generally, it is given by the formula Kt1 T2 divided by T1 plus T2. But suppose it is half. Let's take a value and understand. Okay. So if this gain is currently equal to half, can I, if the gain is currently equal to half, can I increase the gain of the system so that it remains stable? Can you increase the gain of the system? Do you have any particular margin to increase the gain of the system? Yes. And if you can increase the gain of the system, by how much you can increase the gain of the system? By how much you can increase the gain of the system? You can maximum increase the gain of the system. See, this gain is equal to 1. This gain is equal to 1. So my current gain is half. I can double the gain. I can amplify the gain by a factor of 2, and 1 by 2 into 1 will be equal to 1. And as the gain becomes 1, you reach the risky point. Matlab, there comes the point where the Nyquist plot is intersecting -1, 0. System will be marginally stable, and if you increase it beyond it, the system becomes, okay, if you increase it beyond this, suppose you write down 1 by 2 into 3, so that becomes 1.5, and 1.5 matlab now the point P crosses the distance 1 and the system becomes unstable. So you can play with the gain of a system, but up to a certain limit, up to a certain margin. Got it? Up to a certain margin only you can increase. Suppose the gain was 1 by 3, then how much you can increase it? I am talking in terms of factor. You can increase it plus 2 by 3, but don't talk in terms of plus minus, talk in terms of plus. Okay. So now I can increase it by a factor of 3 so that it remains 1. Okay, that means whatever is the current magnitude, you can multiply by its reciprocal. So suppose if the current magnitude is m, okay, suppose the magnitude at this point is m. If I generally take this as m, so what will be the margin such that the gain can be increased? Guys, that I will be calling it as gain margin, and that is 1 upon m, the reciprocal. Whatever may be the current value, take the reciprocal, right? Take the reciprocal of that. So 1 upon that magnitude, and this margin, okay, by which the gain of a stable system can be increased before it reaches the point of instability, that is the marginally stable point, is known as the gain margin of the system. 1 upon magnitude. Guys, which magnitude? Formula mein I have to write the correct thing. So which magnitude? Here I was telling the magnitude m. This is the magnitude at the point P. Okay, point P is known as the phase crossover point. So given the GSHS, you will find the magnitude at the omega P. That is what I have written. Mod of Gj omega P, Hj omega P at the frequency omega P, and take the reciprocal. It is like 1 by m. And that margin by which the gain of a system can be increased is known as the gain margin of the system. Matlab, there is a margin with the system such that you can play with the gain. You can increase the gain. Okay, but up to a certain limit. Beyond that, what does the gain margin give you? An information. It gives you an information that you can, suppose the magnitude was half, like the last example. You can double the gain, but not more than 2 times. Otherwise, the system becomes unstable, and then it is practically of no use. Okay, so what is the gain margin such that the system remains stable is known as the gain margin in the decibel form. Now, I told you now I will be talking about logs and decibel. Okay, why decibel is important, why do we use log and all. Well, I'll make this everything clear once I start the Bode plots tomorrow. Okay, why log, what is importance, what all you can achieve by taking log, why decibel scale is taken, I will explain it tomorrow. Okay, but because we are also going to refer the gain margins from the Bode plots, so commonly the gain margins, this is known as the absolute form. Okay, and then the gain margin in the form of decibel. Commonly it is taken in the form of decibel so that you are able to read from the Bode plot also. And that is 20 log 1 upon mod Gj omega P Hj omega. Just take the 20 log of this. Okay. Just take the 20 log of this. Why 20 log we take? I'll explain this tomorrow. Okay. Yeah, definitely, Anu. Vice versa, you can also think you can make an unstable system to stable by decreasing K here. If I talk with this example only, you can decrease the gain so that you can make the system stable. All right. Now, pay attention to one more point. Guys. This is also important to listen. Then we go towards the next concept. Pay attention. Now, suppose this magnitude is half. So what is the gain margin? It is 1 upon half, that is equal to 2. That is what is this factor multiplied by 2, right? Okay. Now, in the form of decibel, this gain margin will be equal to 20 log 2. If the absolute value is 2, the gain margin in decibel is 20 log 2. Okay, and that is going to be positive. Okay, what is the property of log x? What is the property of log x? Log any base. Okay, it will be positive if x is greater than 1. It will be negative if x is less than 1. Yeah, 6 dB will be the exact answer. Okay, and the log x will be equal to 0 if x is equal to 1, because log 1 is always equal to 0 to any base. Okay. So, guys, whenever you put a quantity inside log which is greater than 0, whenever you put a quantity which is greater than 1, the answer of log will be positive. When you put a quantity which is less than 1, the answer will be negative. And when you put a quantity which is equal to 1, log 1 will be equal to 0. Now look at this graph. Look at this graph here. Whatever may be the value of m, whether it is half or 1 by 3, it is less than 1. Na? This is 1. Okay. So here the magnitude is less than 1. So when you take 1 upon magnitude, when you take the reciprocal of this, it is greater than 1. So in decibel, when you put, like this is coming as 6 dB. Whenever you put in decibel, 20 log 1 upon m will be positive, because 1 upon m is greater than 1. Understood this point? So gain margin will be positive in decibel if the system is stable. And if it is unstable, okay, this is m. This time the m is greater than 1. Okay. So 1 upon m will be less than 1. और जैसे ही log के अंदर put किया, log के अंदर if x is less than 1, the answer will be negative. Okay. So gain margin in decibel will be negative. Okay, and here the magnitude is just equal to 1. Okay, so gain margin is also equal to 1 upon 1, and what is 20 log 1 is 0 dB. Okay, I will put this as a comment. Don't worry, I have a slide. I have written all the comments. Just keep on understanding. There's a rough calculation. I will erase them, otherwise so much of hosh posh. I hope you have understood what I wanted to say. So this is using the basic results of log. It means that for stable system, the gain margin will be positive in decibels. For unstable system, the gain margin will be negative in decibels. And for marginally stable system, the gain margin will be 0 decibel. Okay, in the form of decibel. Okay, stable system positive, unstable negative, and marginally stable 0. This is also a way to analyze stability. Okay, suppose they give you the gain margin of a system. Whether it is positive or negative can decide the stability of the system. Right? And this is the final formula for gain margin. Understood till now? Now, moving towards the next concept. Don't worry, all the positive, negative results I have put together as a conclusion. I will give that conclusion slide for you to take screenshot. Now, understand the next concept. Now, again, considering the same scenario, same plot. Okay, same plot, 1 upon s, 1 plus st1, 1 plus st2. Same example, I am not leaving that example. Okay. This is the point P. This is our important point P. This is known as the phase crossover point. Okay. Now, the phase crossover point is within -1, 0. Why? Because I have taken a unit circle. Here I have taken a unit circle. Here the unit circle is important. Now, unit circle obviously has what radius? Okay, so I am talking about a circle having radius equal to 1. Okay, and center obviously 0, 0. So if the radius is 1, this point will be your important point, which is used for stability analysis, and that is -1, 0. And as you are able to see, point P is inside. So this is stable picture. I will just hide my view. Yes, as you have learned in the previous analysis, point P is before -1, 0 to stable. If it is after -1, 0 unstable, and if it is exactly passing through this point, then it is marginally stable. So here I have taken the point P before -1, 0. That is why I am talking about this as a stable system. And now consider another important point where the Nyquist plot crosses the unit circle. This red line is the unit circle. Okay. where the Nyquist plot crosses the unit circle. And now calculate the phase. See, this is the phase. Calculate the phase in the clockwise. I have measured it in the clockwise. You are able to see. I'm moving in the clockwise direction. Calculate the phase of GSHS at the point G. Now, how do you calculate the phase of point G? Complex number मैंने बोला ना आपको basic. You will join the point with respect to origin and then take the angle subtended by the x-axis, positive x-axis. This is the positive x-axis. Okay. Only thing is I'm going clockwise, so whatever may be the result, I will put the minus sign. Okay. So I have calculated, I have taken a point G where the Nyquist plot cuts the unit circle, and now let us see the phase. In the first discussion I have spoken about the magnitude. Now I am going to talk about the phase. Okay. Now can you adjust this phase? Can I increase this phase a little bit, guys? What will be the effect of increasing the phase? Can I increase it little bit? And if yes, if I can increase it, by what amount I can increase it? By what amount I can increase it? Okay. Now, obviously the same criteria like last time I was telling, can I increase the gain? Yes, you are able to increase the gain up to a certain point such that you cut the marginally stable system. You reach the marginally stable system. So again, I am asking you a question. Can I change the phase? Okay. If yes, by what amount? You can be able to change the phase up to the system is stable. It should not go unstable. Yes. So yes, we have a particular margin for phase change, and that is again moving in the clockwise direction only. Okay, I can make this point. Look at this. Changing the phase matlab rotating the point. Rotating the point. Look at this. Just follow my pointer. Just a second. Yes, just follow my pointer. I am at the point G right now, and I am changing my phase in the clockwise direction. I am changing, but changing up to certain limit. I am going to touch the point P. I am going to touch the -1, 0. I come here. Okay. Just follow my pointer and then let us change it more. So I change it. And if I change it, see the point G reaches here. And obviously if the point G reaches here, the shape of the Nyquist plot is also changed, and the point P, I will mention the point P also here. This becomes your point P. Okay, and -1, 0 comes inside the point P, and hence the system will become unstable. Okay, so what is the margin by which you can change the phase? Is this arrow. Okay, it's being hidden here. I will just show it. Just a second. I'll just change it. Yeah, it is going out of the vision. Just a second. Now it comes inside. I've just reduced the diagram. Okay, now you are able to see. Look at this. Shifted the diagram. Everything has been shifted. Yes. So this was my important point. -1, 0. -1, 0. Okay, earlier the point B is before the -1, 0, so the system was stable. Okay, this is my important point G, where the Nyquist plot cuts the unit circle. Okay. And I was talking about changing the phase of this. Yes, I can change the phase of this by this much of margin. Okay, by changing of this much on margin, as I have shown with my pointer right now, the point G comes, okay, and touches the -1, 0, and -1, 0 पे जो point touch होता है, that is also known as P. So point P and G becomes equal, the system is marginally stable, and beyond that, if you increase, the system becomes unstable. Okay, the system becomes unstable. So I have a margin by which I can change the phase of a system. Can I say like that? I have a margin by which I can change the phase of a system in clockwise direction, and that is known as the phase margin. Okay. No, dollar. The shape is almost the same, but because you are moving the shape is moving. The nature of the shape is unchanged. It is just moving. Plot is not changing, it is moving ना. तो अगर आप फेस चेंज करोगे तो फेस तो सारे पॉइंट का चेंज होगा ना. तो फेस तो सारे पॉइंट का चेंज होगा. तो it is not like you can change the face of one point. ठीक है. The whole face phase equal to angle Gj omega, Hj omega will be changing. The whole phase angle Gj omega, Hj omega will be changing. So overall Nyquist plot will make a clockwise movement. Overall plot is moving in the clockwise direction. See, even ये जो last tip है, even this last tip, this is also moving clockwise. It reaches here. It moves further clockwise and it reaches here. It reaches here. Okay. So changing the phase means changing the phase obviously of the total system. Okay. But for stability, we want to look into -1, 0 and -1, 0 lies on the unit circle, and that is why I'm interested in the point G. That is why I'm interested in the point G. So once again, I repeat, the nature of the shape is same. Nature has not changed, but the whole plot is moving. A whole plot is getting movement along. Okay, movement along a particular direction. Now listen to me. This is my phase margin. How to evaluate this phase margin? How to evaluate this phase margin? Okay. Suppose I tell you, you should be able to tell me with this. Suppose I tell you, I told you this is clockwise. Suppose this phase is, suppose this measure is 120 degree. So what is the phase? What is the phase? It is actually written as -120 degree because it is clockwise. Because it is clockwise. Can you now say me what is the phase margin? By this example, you should be able to tell me. What is the phase margin? What is the phase margin? If this 120 degree, I can rotate it by how much such that I reach this? Phase margin I am asking. Yes, it is 60 degree. It is 60 degree. Okay, by how much you can rotate your plot in the clockwise direction such that it remains stable? It is 60 degree. Because once you reach the second graph, marginally stable clear ho gaya na? Once you reach marginally stable, the phase there is -180 degree. The phase there is -180 degree. So this phase margin will become 60 degree in that case. So how to evaluate this phase margin? This phase margin, guys, should be equal to, this phase margin, guys, should be equal to 180 minus 120, correct? 180 minus 120, and that is equal to 60. Okay, and this is equal to 180 degree plus minus 120, and I will write it as 180 plus whatever. Here the phase was minus 120, but whatever may be the phase of Gj omega, Hj omega, but at what frequency? At omega g. ठीक है, first calculate the phase at omega g. कैसे phase calculate किया? Join this with respect to origin. आपको graphically नहीं करना, you will solve the question by formula. Okay, calculate the phase here. The phase will be negative because I'm measuring clockwise, and 180 plus this negative quantity, 180 plus this negative quantity given me a positive answer. ठीक है. Now suppose what will be the phase margin for the second case? ठीक है. It will be 180 degree. Here there is no margin, na? 180 degree plus what is the phase? Minus 180 degree, and that is 0. For the third case, now because you have moved it more, so what is the angle? It is greater than 180. Mod of the angle is greater than 180. Mod of the angle is greater than 180 degree. Suppose it is minus 210. Minus again because it is clockwise. Suppose it is minus 210. So what is the phase margin? It is 180 degree plus minus 210, and that is equal to minus 30 degree. ठीक है, minus 30 degree. That is equal to minus 30 degree. ठीक है. चलिए कहाँ formula applicable है that we will see with the question. Just wait for the question. So here it is minus 30 degree. Here actually why negative? Because actually there is no margin. The already system is unstable. Already the system is unstable, and because it is unstable, the phase margin is coming as negative. That means for stable system, the phase margin should come up as positive, like this is 60 degree. Okay. Now definitions. अभी तक मैंने definition नहीं बोला. To calculate the phase margin, first you will calculate the gain crossover frequency. I told the point G. I will write down here. I told the point G, that is known as the gain crossover point, and the gain crossover point is the point. The gain crossover point is the point at which the Nyquist plot cuts the unit circle, and the frequency at which you cut the unit circle is known as the gain crossover frequency. Okay, the frequency at which the Nyquist plot intersects the unit circle is known as the gain crossover frequency. Now, how will you calculate this frequency in the formula? Okay. How will you calculate this in the formula? This is graphical analysis for understanding of the concept. How will you calculate in the formula? In the case of formula, okay, unit circle, if you are cutting a unit circle, the magnitude will be equal to 1 because the radius of the unit circle is 1. So how to calculate omega g in the formula? Take the mod function and equate the mod equal to 1, you will get the omega g. Okay. Now once you get the omega g, what will you do? Okay, once you get omega g, you calculate the angle at omega g and add that angle to 180 degree. Add the angle to 180 degree. Add the angle to 180 degree, you get the phase margin. So phase margin is this formula, 180 degree plus angle Gj omega g Hj omega g. Okay, and phase margin is defined as the margin by which the phase of a stable system can be changed before the system reaches the point of instability. That is known as phase margin, and the standard unit of phase margin is degrees. The standard unit of gain margin is decibel. The standard unit of phase margin is in degrees. Okay, it is in degrees. Okay, and what we have observed, look at these points also. What we have observed for stable system, gain margin was positive. Also, the phase margin is positive. The phase margin 60 degree, that is positive. For unstable system, what was my gain margin? Negative. Look at this. Unstable system gain margin was negative. Here, unstable system phase margin is also negative. Okay. For marginally stable system, phase margin is 0. What was my gain margin? That is also 0. 20 log 1. That is also 0. Okay. So I am coming to some important conclusions. Okay, they are very important for you in the at least solving some questions very short method. Say for a stable system, both GM and PM are positive. For unstable system, both are negative. Okay, for unstable system, both are negative. For marginally stable system, both are 0. That means they are both of same sign always. It is not possible that the gain margin is positive and phase margin is negative. They are always of the same sign. Keep this in mind. They are always of the same sign. This will help you in marking some options. MCQ question mein helpful hoga. They are always of same sign. If they both are positive, stable system. If they both are negative, unstable system. Both equal to 0, boundary, that is marginally stable system. Okay, and then relative analysis. Consider two systems. Suppose I design two systems having the same gain margin, but the system having the more value of the phase margin is said to be more stable. The system having more value of the phase margin is said to be more stable. Okay. Now consider two systems. Suppose they have the same phase margin and the one having the more value of gain margin is more stable. So the gain margin and phase margin are now also used to compare the stability. जिसके पास ज़्यादा margin है, ठीक है, that is said to be more stable. The system having more gain margins or more phase margins are said to be more stable in general, and that is how you balance. That is how you weight stability. That is how you weight the stability. Oh, the video is still stuck. As I told, maybe Monday, tomorrow is Sunday. Maybe Monday I am expecting, I am telling you now, new devices are yet to be received. Maybe by Monday or maximum Tuesday I should receive. It has been couriered by the office. So maximum by Monday, Tuesday it should receive. Then we'll not have such problems. Okay, for some time let us continue. फिर मैं अभी screenshots पे जाने वाला हूँ. Then I will improve my camera. All right. Okay. Now, also this is important for solving some MCQ question. The relations between omega g, omega p. So remember this trick. Remember this trick. Look at this. I will better hide my view. It is not working. Look at this, guys. This is omega g. Okay. And you know, this is your diving angle. So this represents infinity plus. Okay. And this is your starting point 0 plus. So matlab you are going from 0 say infinity. This is the increasing direction. This is the increasing direction. So in the increasing value of omega, who comes first? G or P? सबसे पहले G आ रहा है for stable system. So whenever the G point is first as compared to P point, we have a stable system. When they are overlapping, when the G and P are overlapping, it is marginally stable. And when the G comes next and P comes first, it is unstable. That can also be used to check the stability in certain cases. So when the G comes first, when omega G less than omega P, it is stable. Omega G greater than omega P, unstable. And omega G equal to omega P hoga for marginally stable system. All right, you can use these key points in solving questions. Okay, time for screenshots, and then we will start solving the question, how to solve the questions. Start from this one. Start taking the screenshots from this point. Next one. Next one. Aruna, it may be measured clockwise, anti-clockwise. Actually, there is no hard and fast rule. But as a convention to define phase margin, I have taken it as clockwise. It's taken as clockwise for calculating phase margin as a convention. Next screenshot. Now, Nikhil, it is 180 plus angle GJ omega HJ omega. Next screenshot. Next one. Next one. And guys, a question. Now, guys, a question on screen. Please take down this question. By the time I'll just work out with the camera. For the system, GSHS equal to 7.5 by S, 1 plus 0.2 S, 1 plus 0.4 S. Determine the omega P and gain margin. Next, omega G and phase margin. Let's continue. Let's calculate this in continuity. First, omega P and gain margin. See, now I'll tell you both the methods here. Focus everyone. Let us solve this. See, by direct formula also you can say, if you are able to remember the direct formula, or I'll tell you the method, the analytical method also. By direct formula, because this is the same transfer function, as we have derived, as we have taken in the derivation. So what is omega P? That is equal to omega C. That is the critical frequency. अभी मैं केवल उसको ओमेगा पी बोलूंगा, and that is 1 upon root T1 T2. Okay, by the direct formula, if we take from where we started, 1 upon root T1 T2, this one. Okay, this is the one. Okay. No, which derivative? Dash. No, Zain. That's not a derivative. That's actually a comma. I think it is not properly placed. Just make a correction. Just removed it. That was a comma. It was not properly placed. That's not derivative. Okay. It's k upon s, 1 plus st1, 1 plus st2, the same function. Okay. So using this formula, I can write down the answer as 1 upon under root of T1, which is 0.2, and T2, which is 0.4. That is 1 upon under root of 0.08. So what is this omega P? Let us calculate this under root. And this is coming up as, this omega P is coming up as 3.535 or 3.54 radian per second. Okay. This is by the direct formula. Okay. But what is the analytical method? Suppose any other GSHS may come now. Okay, we are not going to derive the formula for everything. I have given you the formula. Okay, so by general method, okay, by the general method, how will you solve? Understand this, and same calculations we may apply in many questions. By the general method, at omega equal to omega p, how will you solve omega p? Phase crossover frequency. At omega equal to omega p, you will equate the phase as plus minus 180 degree. Plus minus 180 degree. Commonly minus 180 use में आएगा because mostly the phase are in negative form. So GSHS, what is GJ omega HJ omega given to you? GJ omega HJ omega given to you is 7.5 divided by S, that is J omega, 1 plus 0.2 J omega, 1 plus 0.4 J omega. Okay, so what is the phase function? The phase will be, you all know to calculate phase now. We have been doing it several times in the Nyquist. Numerator is positive real number. Directly come to denominator and minus लगाते जाएंगे denominator के साथ. तो minus of 90 because pure imaginary term, minus 0.2 omega minus tan inverse 0.4 omega. Okay, and once again, like critical frequency, here also, to get the omega p, you will have to simplify the tan inverse first. So this phase will be equal to minus 90 degree minus tan inverse. Minus common लेंगे तो tan inverse A plus tan inverse B. So tan inverse A plus B divided by 1 minus AB divided by 1 minus AB. So phase is equal to minus 90 minus tan inverse 0.6 omega divided by 1 minus 0.2 into 0.4, 0.08 omega square. Okay. Okay. Yes, numerator ransom is correct. Tan inverse A plus tan inverse B is tan inverse A plus B upon 1 minus AB. So 0.2 omega plus 0.4 omega. Now, what is how to calculate? I want the phase as equal to minus 180. Okay. The phase should be equal to minus 180 degree. That means minus 90 minus tan inverse 0.6 omega upon 1 minus 0.08 omega square should be minus 180. Why I am choosing minus 180? Because all the terms are minus, so minus minus cancelled, and then you get tan inverse 0.6 omega upon 1 minus 0.08 omega square equal to 90 degree. And how do you get 90 degree? Tan inverse infinity is 90. And how do you get infinity? How do you get infinity? If you equate the denominator to 0, 1 minus 0.08 omega square equal to 0. This frequency will be named as omega p. So what is omega p square is 1 upon 0.08. Same result now. Omega p is ultimately 1 divided by root 0.08, and that is same. Ultimately same. यही हमने calculate किया था 1 upon root 0.08. 1 upon root 0.08, and that is coming up as same answer. I will write down 3.54 radian per second. 3.54 radian per second is the phase crossover frequency. It will come up as same only. But why I told the general method? Because every time यही function पे question नहीं होगा ना. It can be any GSHS given. Okay, so you will start solving by the general formula. Okay. Now, omega p के साथ comes the gain margin. So let us calculate the gain margin, guys. What is the gain margin? Let us calculate. Okay, so for gain margin, we will first calculate at omega equal to omega p. What is the magnitude? Which magnitude? No, Sarthak, not the correct calculation for gain margin. If anyone has completed, please you can say that. Okay, what is the magnitude mod Gj omega Hj omega? And that should be equal to, look at this, इसी का magnitude लेना है, तो 7.5 is as it is, 7.5 divided by omega, then under root of x square plus y square, complex number का magnitude. So under root of 1 plus 0.2 square is 0.04 omega square. ठीक है, omega p divided by, here also omega p, 1 plus what is the next term? 0.4. The 0.4 square will be 0.16 then into omega p square. Okay. Zishan correct answer. Shubham not correct. Shubham not correct. Now put down omega p. Okay. Put down omega p equal to 3.53, 3.54, whatever. Okay, approximately you can put, and magnitude will come up as, see, I'll just solve the calculations. 0.04 omega square. Omega square तो direct आ जाएगा ना. Omega square is actually 12.5. So accordingly, I will take 1 plus 0.16 omega square Yes. What is the answer that I am getting after calculation? It is 1.0015. That is approximately 1 only. That is approximately 1. Aruna, decibel mein 1 nahi hai. That is approximately 1. Okay. So in the decibel scale, what is the gain margin? That is given by 20 log 1 upon this magnitude. 20 log 1 upon mod gj omega hj omega p. Okay, I am writing directly the absolute decibel answer, and that is equal to 20 log 1 by 1, that is 20 log 1, and that is 0 dB, and that is 0 dB. Okay, and guys, because of this, the second question is automatically solved. See, you have to use your key pointers. Second question is automatically solved. Gain margin is 0 dB, signifying that the system is marginally stable. And if the system is marginally stable, two conclusions will follow. Phase margin is also 0, need not calculate, and omega g will be equal to omega p, that is कितना था हमारा 3.54. 3.54. That is automatically followed. So second question is also done. Okay, that is just by our conclusion. Second question था ना, find omega g and phase margin. That is also done. So because the system is marginally stable, you can use the conclusion. That is why those key pointers are important. Remember them, save them. Phase margin is 0 because marginally stable system, and omega g will be equal to omega p, that is 3.53. Okay. Even if you calculate directly 110%, you will get that. 110% you are going to get that. उसमें कोई doubt नहीं है. 110% you will get the same value if you solve by the formula of phase margin. वो formula भी use होगा आने वाले question में, but for this question it is not required. For this question it is not required. Okay. So now suppose this is a ESE question I am taking. Now suppose if you have a function of the form 1 upon s, 1 plus st1, 1 plus st2, because this is a common data, this is a very common type of function. So at least for this you can remember, you can directly solve by the formula. See, if such a function is coming, you can directly use by the formula. What is omega p? 1 upon under root t1, t2, not necessary to use the general method. So 1 upon under root of 0.2 into 0.05, so that is 1 upon, ये कितना हो जाएगा, 1 upon under root of 2510 and 0.01, ठीक है, 0.01, that is 1 under root of 0.01 is 0.1 and 1 upon 0.1 is 10. Yes, option number B is correct. 10 radian per second. 10 radian per second. Because it is the same function, k by s, 1 plus st1, 1 plus st2. Direct formula से we can solve such case. If it is the function k by s, 1 plus st1, 1 plus st2. हर जगह ये apply मत करना. If you blindly apply this everywhere, then you are going wrong. This is just for k by s, 1 plus st1, 1 plus st2. ठीक है? चलिए guys, screenshot. Screenshot for these two questions first. Next screenshot. Next one. Next. Next one. Next screenshot. Next one. Okay. Yes, guys, can you answer this question? The frequency response of a linear system Gj omega is provided in the tabular form below. What is the gain and phase margin of the system? What is the gain and phase margin of the system? What is the gain and phase margin of the system? Now, plots are not given, na Nyquist plot, neither there's Bode plot, just the phase and magnitude information of the system is given in the tabular form. Can you find the gain and phase margin of the system? Yeah, Zayan correct? No, Yugandhar, not exactly correct. Recheck. Yes. Vaishnavi correct? Yes, yes, guys. So all coming correct now. A is the correct answer. A is the correct answer. See, guys, for gain margin, you need omega p first of all. Omega p is the frequency at which the phase is minus 180 degree. Okay, the phase is minus 180 degree at this point. At this point. Okay. There is a frequency. What is that frequency? It is not given, neither required also, but there is some frequency at which the phase is minus 180 degree. Okay, suppose that frequency is omega p. Okay, so what is the gain margin? It is given by 20 log of, using the formula 1 upon magnitude, 1 upon magnitude at omega p. Okay, so that omega p is not known to us, but what is the magnitude at this point? That is known to us at least. What is the magnitude at this point? 0.5. So put down this value. Put down this value. Solve it here. 20 log of 1 upon 0.5. That is 20 log to 6 decibel. 6 decibel. Okay. 6 decibel. Then for the phase margin, you need omega g. Where is omega g? Omega g is the frequency at which, what was the omega g definition? The frequency at which you cut the unit circle. Matlab mod of gj omega should be equal to 1. Where is mod of gj omega equaling 1? Where is mod of gj omega equaling 1? That can be seen in the table. Mod of gj omega equal to 1. Here it is. Here it is. So I can relate it here. Yes. This is mod of gj omega and the phase is minus 180 degree. Okay. So what is the phase margin formula? It is 180 degree plus the phase at plus angle gj omega g. What is the phase at that frequency? The phase at that frequency, as in the table, corresponding phase minus 150. 180 plus minus 150, 30 degree. ठीक है. अच्छा, by chance आप ये भी सुन लीजिए, if you only calculate gain margin, that is sufficient. 6 dB positive है, phase margin will also be positive. Option number A solved. Option number A, you can mark by that. Blindly you can mark. Both are positive or both are negative. They cannot be of the opposite sign. They cannot be of the opposite sign. ठीक है. Mark the option blindly. Gain margin positive. Now, nahi Jyotsna. For that you'll have to go into some plotting. No, not from this table you will not be able to do. Okay. So both positive. Gain margin 6 dB. तो face margin और कोई option नहीं है ना, both positive वाला. That is why option number A is correct. Right. Screenshot for this question. Take the screenshot for this question. Now next question. Guys, some question will have a special attention also. Special points. I will mention some special points with the question. Gain and phase margin of a feedback system with this GSHS given. With this GSHS given. Can try a little bit. At least you can tell me the omega p. Rest I will help you. There's a special consideration inside this question also. Can you say me the omega p value? No, Aruna and Amit, not the correct final answer. No, it is not correct. No, Yugandhar, not the correct answer. A is not correct. A is not correct. Shiva Shankar, Dev Kumar, A is not correct. Shubham and Zayan, correct. Deepa, correct. All right. Chaliye, so I shall explain you the concept behind this. The gain and phase margin. So first of all, what is GJ omega, HJ omega? Yes, good afternoon, Sai Tarun. It is J omega divided by J omega plus 100 power 3. J omega divided by J omega plus 100 power 3. Okay. What is the magnitude and phase function? Let us write it separately. What is the magnitude and phase function? Magnitude is J omega ka magnitude is just omega divided by J omega, matlab omega square plus 100 square under root of this and power 3. So raised to the power 3 by 2. Okay. And what is the phase function? Phase will be numerator is J omega, that means 90 degree. ठीक है, प्योर इमेजिनरी 90 डिग्री न्यूमरेटर के लिए पॉजिटिव एंड फॉर डिनोमिनेटर माइनस j omega plus 100 मतलब tan inverse omega by 100 imaginary by real but it is cube. Okay, so this angle will repeat 3 times, so minus 3 tan inverse omega by 100. This is the magnitude and phase function generally. Okay, so now at omega equal to omega p, at omega equal to omega p, the phase has to be equated to minus 180 degree. So 90 minus 3 tan inverse omega p by 100 is minus 180 degree. So 3 tan inverse omega p upon 100 is equal to 270 degree. Okay, cancel 3. So you have tan inverse omega p by 100 equal to 90 degree. And how it can be equal to 90 degree tan inverse? When inside you have infinity. So omega p tends to infinity. Now undefined frequency. Infinity is something known as undefined. ठीक है, ये एक स्पेशल पॉइंट है जिसको मैं मेंशन करूंगा, बट लेट मी कंप्लीट नॉर्मली. ओमेगा पी इज अनडिफाइंड हियर. ठीक है, so there is no finite phase crossover frequency. Now let us go with the regular flow right now. Omega p tends to infinity. Now at omega equal to omega p, that is infinity, what is the denominator is just 1 plus st, not 1 plus st1, 1 plus st2. Every term will have a different polar plot, na Aruna? Okay, what is the magnitude? So magnitude will be, see, omega upon omega square plus 100 square power 3 by 2. Infinity by infinity पर किसका डिग्री ज्यादा है? Denominator का डिग्री ज्यादा है. So it is going to be 0. It is almost like 1 by infinity form, and that is 0. Okay. And this magnitude is 0. See guys, if you were telling answer 0 because of magnitude, so nahi, the gain margin is not equal to magnitude. The gain margin is 20 log 1 upon this magnitude, 1 upon magnitude at omega p, and that will be equal to, this is equal to 20 log infinity, and log infinity is infinity. The infinite decibel is the gain margin. Infinite decibel is the gain margin. Okay. Infinite is the gain margin. Okay, now what about the phase margin? What about the phase margin? Okay, let us calculate the phase margin. Now, Aruna, you can convert to 1 plus st by taking 100 common, but it is not 1 plus st1, 1 plus st2, 1 plus st3. Okay, this is 1 plus st repeated thrice. This has a different polar plot. This has a different polar plot. Okay, so gain margin is infinite decibel. Now coming to the phase margin, and for the phase margin, I need omega g. Okay. Yes, Yugandhar. Yes, Yugandhar. It leads to the conclusion. Highly stable system. Okay. Now listen to the omega g. Listen to the omega g now. At omega equal to omega g, the magnitude should be 1. How do you calculate omega g? By equating magnitude to 1. So what is my magnitude function? In the first slide, I will just take the magnitude function, that is omega upon omega square plus 100 square raised to the power 3 by 2 is equal to 1. So omega is equal to, yeah, let me take the square only, omega square equal to omega square plus 100 raised to the power 3. And to simplify the calculation, put omega square equal to x. Put omega square equal to x. So you have x is equal to x plus a. Let us keep the calculation simple. Also put 100, 100 square that too. It's not only 100. Okay, put 100 square equal to some constant a. So it is x plus a whole cube. So I am going to get an equation, x is equal to x cube plus a cube plus 3a square x plus 3ax square. So ultimately, just a second. So ultimately, I am getting x cube minus 3x cube plus 3a square x plus 3a square x minus x, so plus 3a square minus 1 into x plus a cube equal to 0. Now just pay attention that if I even put down the value of a, what is a? A is 100 square. Okay, that means a itself is, a is 100 square, that is actually 10 raised to the power 4. 10 raised to the power 4. So 3a square, that is 10 raised to the power 8x plus 3 into 10 raised to the power 8 minus 1. कुछ ना कुछ mistake हुआ है. 3ax square है. This is 3ax square, the second term. So 3 into 10 raised to the power 4x plus 3 into 10 power 8 minus 1 plus a cube will become 10 raised to the power 12 equal to 0. Please see that. Please see that. Do not worry about the calculation because it's a GATE 2003 question where scientific calculators were there. Okay. But still I am taking this question from GATE 2003 because there is some conclusion, there is some general effect which I will be able to tell you. So because it's GATE 2003, so let's use this scientific calculator to solve for the roots. To solve for the roots of this cubic equation. Now see guys, let us not involve the exact values of root. The x which I am getting, but what is x? What is x? It is equal to omega square. That also you must remember. X is equal to omega square. That is coming to be, one of the root is coming to be negative. Okay? Or the other two roots are coming as complex conjugate. Complex conjugate. So when you take the omega, whether it is under root of complex number or under root of negative number also will give you a j1. Will give you a j term. So what is omega? There is no real omega. There is no real omega. Okay. So for this function, So for this function, guys, omega g actually does not exist. Omega g does not exist for this function. Omega g does not exist for this function. ठीक है, there is no frequency. ठीक है, there is no frequency, no real frequency. ठीक है, at which the polar plot, at which the Nyquist plot, by the calculator, Shubham beta, just use your scientific calculator, crosses unit circle. And because it is anyways not going to cross the unit circle, okay, so how much phase can be changed? By what margin you can change the phase of the system so that it reaches -1, 0, so that it reaches the point of instability, that is -1, 0. So how you can change it? How much you can change it? जितना चाहे change कर लीजिए. It is never going to intersect the unit circle. ठीक है. It is never going to exactly last year. It is never going to intersect the unit circle. That means it is already rotating inside the unit circle, and phase margin will be infinite degree. जितना चाहे phase को change कर लीजिए. How much you want? How much you want, you can change it. How much you want, you can change it. Phase margin is infinity. Now, what is the question given? GSHS is, I'll just copy the question here. GSHS is equal to S upon S plus 100 whole cube. I will show you the quick analysis of this. ठीक है, कुछ question में I'm going in details to make you understand the concept. Don't worry. So what is the theta starting angle for this? It is -90 degree into, now there is no poles at origin, but there is zeros at origin. So let's take this as -1. So it is 90 degree, theta starting, theta diving, -90 degree into P minus Z, that is 3 minus 0, 3 minus 1, 3 poles and 1 0. So that is -180 degree. Approximately its shape I am giving you quickly by the starting and diving angle. Approximately the Nyquist plot of this, the polar plot of this, diving is -180 degree, matlab along the negative x-axis, and starting is along the positive y-axis, and the plot is approximately this. Rest, if you want to find all the critical frequency, that you can, if you want to find all the critical frequencies, that you can do anyhow. Just a second, it got erased. So the plot will start along the positive y-axis 90 degree and dive into the origin 180 degree. This is the polar plot approximately. This is the polar plot approximately. Okay. And as seen in the calculation, I was trying to equate the magnitude equal to 1. So what is the frequency at which the magnitude equal to 1? There is no real frequency at which the magnitude is equal to 1. That means this polar plot, is always inside the unit circle. It is always inside the unit circle. So the phase margin is negative. Oh, sorry, phase margin is infinity. Okay, is infinity. It is always inside the unit circle. Okay, not only on the left hand side, even if I extend this, just if I take the complete unit circle also, it is inside the unit circle. It is inside the unit circle. That is the approximate polar plot of this. Okay. अच्छा, यहाँ पे आप ये भी देख रहे हैं कि if at all there is any phase crossover frequency as seen from the plot. Okay, that's seen from the plot. What was my omega p by the calculation? Phase crossover frequency infinity. Infinity. ठीक है. Infinity मतलब diving angle. So are you actually intersecting? Are you actually intersecting the negative x-axis? Nahi. Even if you are intersecting the negative x-axis, that is at origin. That is at origin. Now tell me gain margin. What is the magnitude at origin? What is the magnitude at origin? Zero ना. So what is the gain margin? Absolute form में भी बोलेंगे तो reciprocal of magnitude. मैंने बोला था ना, if the gain is 1/2, the reciprocal of 1/2, 2. That is the gain margin. So omega p is infinity. Infinity means diving angle. Infinity means diving angle. Diving means diving into the origin. What is the magnitude at origin? 0. So gain margin 1 by 0, infinity. Decimal में भी जाएंगे तो 20 log infinity is infinity. So why the gain margin is infinity? Because even if you keep on increasing the gain of the system, dear, what will happen? Even if you keep on increasing the gain of the system, this point which is here, okay, this point magnitude will increase. This point magnitude will increase, but it is not going towards the, okay, anyways it is not going to intersect -1 comma 0. Anyways it is not going to intersect the -1 comma 0. That is why the gain margin is infinity. Okay, gain margin is infinity. Difference क्या है? Let me go back to the original slides, the first cases where we derived. Okay, here the difference is that you are cutting the negative x-axis. You are cutting the negative x-axis. Okay, at some finite frequency, at a finite magnitude. But in the question that you are solving, you are cutting the negative x-axis. If at all you are cutting at origin. What is the magnitude at origin? 0. So what is the gain margin? 1 by 0 हो जाएगा ना? That is why the gain margin went infinity. That is why the gain margin went infinity. Okay, now this is the complete analysis, better analysis with the Nyquist plot, and I have some points to put down. That is why I have done detailed analysis. I have some points to put down. I will put down now. Okay. If omega p tends to infinity, that is actually undefined. That is actually undefined. That is there is no finite omega p. There is no finite valid omega p. Correct? If at all there is omega p, that is undefined, and that is the diving angle, actually diving into origin. Okay, and when you are diving into origin, the magnitude at origin is 0. I repeat, the magnitude at origin is 0. Gain margin will be 1 upon 0 infinity. Log maybe 20 log infinity is infinity. So gain margin will be infinity there. You can take it as a conclusion. When omega p tends to infinity, matlab there is no finite valid omega p. There is no finite valid omega p. Gain margin tends to infinity. Okay. Number 1. Now, number 2. Okay. If omega g does not exist, if omega g does not exist, like in this question, omega g, there is no, not यहाँ पे finite और infinite की point नहीं है, it does not exist only, there is no frequency, neither finite nor infinite, but there is no real omega g that can exist. मतलब the Nyquist plot cannot intersect the unit circle anytime, cannot intersect the unit circle anytime, and that is why how much you can change the face of the system, you can rotate it by how much you want, infinity, 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 जितना उसको turn देना है देते रहिए, system going to be remain stable. So when omega g does not exist, phase margin is infinity. Got it? Just make a proper take care of these points specially. Okay, omega g does not exist, phase margin infinity. Okay, take down a question now. Please take down a question now. The phase margin of a system of an open loop transfer function GSHS equal to 1 minus S by 1 plus S 2 plus S is phase margin, only phase margin. I am interested only in the phase margin of this. Come on, quickly. Think about it, give me the answer. Yes, Sarthak, correct answer. What is Gj omega Hj omega? If I convert into frequency domain, 1 minus j omega upon 1 plus j omega into 2 plus j omega. So what is the magnitude function? The magnitude function, numerator and denominator have the conjugate terms. 1 minus j omega magnitude is also root over 1 plus omega square. 1 plus j omega magnitude is also root over 1 plus omega square. Next is 2 plus j omega, so magnitude is 4 plus omega square. Under root 1 plus omega square cancel and you get 1 upon root 4 plus omega square. For phase margin we need omega g, and at omega equal to omega g equate the magnitude to 1. So 1 upon root 4 plus omega square equal to 1. That means 4 plus omega square equal to 1. omega square is minus 3. Minus 3. And the under root of minus 3 is imaginary number. So once again, there is no real omega g. Square is negative. Okay. So what is my phase margin? Infinity. Whenever there is no defined omega g, the phase margin infinity. Option number D. Mark कीजिए, next question पे जाइए. Got it? Option number D. Option number D. Okay. No, not necessarily true always, Neha. Not necessarily true. Okay. Screenshot for these two questions, guys. Screenshot for these two questions. Then we go towards the next one. Screenshot of this. Next one. दोनों infinity हो ये compulsory नहीं है. Everyone please remember, it is not necessary that both will be infinity. Next one. Next one. Next one. Next one. Next. And next question. Next question. Now here also this question has a special case hidden inside this. This also has a hidden case inside this. Okay, the gain margin for the system with the open loop transfer function GSHS equal to twice 1 plus S by S square is. Gain margin is being asked for the system with open loop transfer function GSHS equal to twice 1 plus S by S square. Okay. Again, remember that gain margin is 1 upon magnitude. Don't say the magnitude answer. Gain margin is 1 upon magnitude. Okay, 1 upon magnitude. Phase is twice of. Now 1 plus j omega. So phase is tan inverse omega. Denominator में j omega 2 times. So 90 coming 2 times. So minus 180 degree. Okay. The question is about gain margin. No, it's not C. C is not there any case. C is not possible. Okay, the gain margin. For gain margin, we need omega p first of all. So here also and special attention. Okay, omega p. For omega p, equate the phase to minus 180 degree. Okay, so what is the phase formula? Tan inverse omega minus 180 is equal to minus 180. Okay, solving which you get tan inverse omega. 180 cancel, it is 0. So what is the omega p? It is just 0. Now once again you are getting omega p, which is the starting angle actually, which is the starting one. Matlab, there is no other omega p. Actually it should be between 0 and infinity. Omega p कहां से निकला है? Critical. Remember, omega p from where it has come? It has come from the critical frequency only. It is a special case of critical frequency. And what are the critical frequency I was taking? I was taking the critical frequency between 0 and infinity. ठीक है. Now, ठीक है. Now, what is the magnitude, ठीक है, at omega p? The magnitude will be, you are able to see here, twice under root 1 plus omega square divided by omega square, but because of 1 by 0, magnitude is infinity. Guys, magnitude infinity hai. Okay, so the gain margin should be 1 upon infinity, absolute form should be 0, and in decibel it should be 20 log 0, 20 log 1 by infinity, and log 0 is minus infinity. So is it mean that option number D? Let's take decibel. Let's take decibel as the standard form again. Is it minus D? No, it is not minus D. No, it is not minus D. Now Shubham, decibel may be minus infinity. Log 0 is minus infinity. Okay. Now, this is not the correct answer. Why? Why it is not the correct answer? I will explain you. See, characteristic equation, if you take, characteristic equation of the system is 1 plus GSHS equal to 0. So, S square plus 2S plus 1 equal to 0. S square plus 2S plus 2 equal to 0, which means that from here, I can comment that zeta is positive and the system is purely stable. The system is purely stable. Okay. But minus infinity gain margin represents what? It represents a highly unstable system. It represents a highly negative matlab unstable. Na? So this is a highly unstable system according to the gain margin analysis. But forget Nyquist plot, gain margin, everything. Come to the most basic analysis where we started. Everything has come up from the characteristic equation and roots of characteristic equation. It is a simple second order system and zeta positive suggests that it is to be stable. This analysis cannot be wrong. This is our fundamental analysis. Okay, so there is something wrong with this analysis. Answer is not 0, not minus infinity. There is something wrong with this analysis. Wrong nahi hai. There is actually no phase crossover frequency only. I will show you with the plot. This is again a special case where you could have made mistakes. That is why I am focusing important points here. जहां पे आप option को incorrect mark कर सकते हो. High probability है getting the incorrect option. But that's why I am giving attention to this question. So what is GSHS given, guys? GSHS yeah, GJ omega HJ omega is 1 plus J omega twice of 1 plus J omega upon J omega square. Okay. By the starting angle, by the diving angle, you can draw its polar plot. You can draw its Nyquist plot. I'll have to first complete its Nyquist plot. Iska Nyquist plot kaisa aayega? See, I'll just tell you here only. What is my starting angle? Minus 180. And what is my ending angle? Will be equal to minus 90 degree. 2 minus 1. 90 minus 90 degree. Okay. This is how the polar plot will come. Okay, this will be 0 plus. Okay, this is diving angle infinity plus. So you see that guys, 0 plus पे face minus 180 to hai, but are you actually touching the negative x-axis? Okay, are you actually touching the negative x-axis? No. You are going parallel to the negative x-axis. That is why the face is minus 180 degree. Second step, take the mirror image. Second step, let me complete first. Take the mirror image. So this is 0 minus. Okay. And join the 0 minus to the 0 plus through an angle of 2 pi. Because number of poles of GSHS at origin is 2 here. So rotate through an angle of 2 pi in the clockwise direction. This is actually the complete Nyquist plot. Where is my point? Minus 1 comma 0, guys. Okay, is it being encircled? Looking from the minus 1 comma 0, I will say that no, it is not encircled because 0 minus is above the x-axis, 0 plus is below the x-axis. So it is not encircled. So n is equal to p plus minus z plus, n is also 0, p plus is also 0. Okay. So solving this, you get z plus equal to 0 means that the system is stable as told by our characteristic equation also. And if a system is stable, okay, its gain margin cannot be minus infinity. Its gain margin cannot be negative. Its gain margin cannot be negative. Okay. Actually, now listen to the important points. When does this Nyquist plot intersects the x-axis? See, definitely this is not the point. According to the calculations, we got omega p is 0, but this is not correct. This is also not correct. This is not a phase crossover frequency. This is not a phase crossover frequency because at omega equal to 0, my Nyquist plot is going parallel to the negative x-axis, but is it touching the negative x-axis? No, it is not touching the negative x-axis. So where is my Nyquist plot touching the negative x-axis? Only at the diving angle, that is infinity plus, and touching at origin. So whenever it is touching at origin, what is the gain margin? Infinity, na? Because the magnitude at origin is 0, so gain margin is 1 by 0, that is infinity. Even if you take in the log scale, 20 log infinity is infinity decimal. Okay, is infinity decimal. So this is not omega p. आपको polar plot से समझ में आ रहा है ना कि how can it be omega p? Omega p is the frequency at which I intersect the negative x-axis, and I'm not intersecting the negative x-axis at 0 plus. This is not omega p. This is not omega p. Okay, this is not the omega p. Okay. If at all there is omega p, that is at infinity, and as in the last question I told, if omega p is infinity, gain margin will be infinite, and the correct answer for the question is infinite only. The correct answer of the question is infinite. I will tell you. The correct answer, IIT answer is infinite. Some of the books will say minus infinite. गलत given है कुछ books में. इसका correct answer plus infinity है. Please mark it. The correct answer is plus infinity. And what is the precaution that you have to follow? कि sir अब ऐसा क्यों हो गया? The only precaution that you have to follow now, what I told earlier, na, that was not a precaution. Earlier मैंने क्या बोला था? If omega p is infinity, the gain margin is infinity. That is not a precaution. That is the result I have given you. If omega g does not exist, phase margin is infinity. But here I am talking about the precaution where you have to keep safety. Okay. If omega p equal to 0 comes from the formula, okay, then don't trust the formula. Then you have to go for the plots or characteristic equation. Okay. Don't trust the formula. Solve by either plots or solve by the characteristic equation. Yes, outer plot will be 2 pi, and Zion, why it is 2 pi? Because ultimately आपको imagine कैसे करना है? You are joining infinity points in the, see, in this finite tablet I cannot sketch infinity na. But what is imagine कैसे करना है? You are going on the negative x-axis at a point which is at infinity. ठीक है, a point which is just above the x-axis and below the x-axis. 0 minus is above, 0 plus is below, but they are both tending to infinity. So when you come from infinity 0 minus and again go back to the same negative x-axis, almost this is 2 pi only. ठीक है, almost this is 2 pi only. आपको यहाँ पे 2 pi नहीं दिख रहा है. 2 pi means circle. Here in this graph you might be seeing कि sir this is not complete 2 pi. Correct, agreed. But because in this diagram I can only take finite values. But where is 0 plus and 0 minus? Infinity. So infinity se if you imagine na, so it is almost one full rotation. Like that 2 pi is there actually. Okay. And the plot has shown me exactly that this is not omega p as told by the formula, but this is not omega p. This is the precaution. Omega p 0, I don't trust the formula. So whatever special cases can exist, I am telling you, otherwise the questions you will make mistake in the questions. Otherwise you will make mistake in the question. Okay, is it clear now? Chaliye, time for screenshots for this question and then we move process. Screenshot for this question. Next one. The next one. The next. Next one as a precaution. Next question now. Yeah, better to take it as a homework. It's a similar kind only. So I give you one question as homework here. Take this as a homework question. The open loop transfer function is given. Take the screenshot and take it as a homework. Okay. Take down the screenshot for this homework question and try this question now. It's a simple one, gate 16 1 mark question. Yes, come on. This is simple. ये कोई यहाँ पे कोई special case uniqueness नहीं आएगी, तो I should expect the answers from many of you now. Phase crossover frequency, only phase crossover frequency, 1 mark question. Yes, guys. So you have started coming with the correct answer, right? Very good. The phase crossover frequency of the transfer function 100 by s plus 1 whole cube in radian per second. In radian per second. Only phase crossover frequency. What is dj omega is 100 by 1 plus s, 1 plus j omega whole cube. So what is the phase function? The phase function is, numerator is positive real number, so directly 0. Denominator के लिए minus tan inverse omega by 1, but it is cube, so it becomes minus 3 tan inverse omega. Okay, and at omega equal to omega p, the phase has to be equated to minus 180 degree. Okay, minus 180 degree. The minus 3 tan inverse omega is minus 180 degree. So what is tan inverse omega? Cancel by minus 3. Tan inverse omega is 60 degree. Okay, and that is achieved at omega p equal to tan of 60, and tan 60 is root 3. Option A, root 3. Yes, all of you given the correct answer. A. Simple question, 1 mark simple question, phase crossover frequency. Omega p is root 3. And then this is a valid omega p. It is a finite non-zero frequency. Here it is a finite non-zero frequency. So you can apply the formula. If gain margin is asked, you can calculate the gain margin as well. Okay. First take the screenshot of this one. Then we go to the next question. Screenshot for this question. Next question. Next question. In the feedback system shown below, Gs equal to 1 by s plus 1, s plus 2, s plus 3. The positive value of k for which the gain margin of the loop is exactly 0 dB and the phase margin of the loop is exactly 0 degree. The positive value of k for which the gain margin of the loop is 0 dB and the phase margin of the loop is exactly 0 degree. 0, 0. Yes. What is the method to be applied here? If you solve by the formula of gain and phase margin, it is going to be lengthy. For this question, formula and gain phase margin will be lengthy. Given that the gain margin of the loop is exactly 0 dB, okay, and phase margin of the loop closed loop system is also 0 degree, that means the system is actually marginally stable. Yes guys, you have come up with the correct answer, also correct method, correct answer. And to check whether the system is marginally stable, for what value of k, you can check by the RH criteria. No need to involve in the gain and phase margin calculation. The gain margin and phase margin is just to given you so that you relate, you that you compare that the answer is marginally stable. Marginally stable ke liye you can go for the RH criteria. And for the RH criteria, I need the characteristic equation, that is 1 plus GSHS 1 upon S plus 1, S plus 2, S plus 3 equal to 0. That will give you the characteristic equation S cube 1 plus 2 plus 3, 6S square, 1 into 2, 11S plus 6 plus k. It will be k here because it is connected in cascade with k. So this will become plus 6 plus k equal to 0. Now you can apply the RH criterion on this characteristic equation. You can apply the RH criterion on this characteristic equation. What it is S cube S square, first two rows. So S cube 1 and 11 alternate coefficients. Next it is 6 and 6 plus k. S power 1 row. 6 into 11, 66 minus 6. So that is 60 minus k divided by 6. Last element of a row is always 0. S raised to the power 0. So this is x into k. X into 6 plus k divided by x. So what is left is 6 plus k. That is 0. Similarly, as I have taught you in the Rauther-Waite, same method you will just apply. We want the system to be marginally stable. The system is marginally stable. That means it should have j omega axis roots. J omega axis roots is possible with auxiliary equation. Auxiliary equation is possible if you have row of zeros. Row of zeros can always occur in the odd power row only. Okay, the odd power means S power 3 or S power 1. Okay, S power 3 or S power 1. Okay, that's very good, Pavan Chandra. Yes, keep on carrying the confidence, then you will be able to crack the exam. So S power 3 to fix that, I cannot make it as 0. Look at S power 1, focus at S power 1. So take the S power 1 row, take the S raised to the power 1 row, 60 minus k equal to 0, k is 60. K is 60. That's it. K is 60. Take the screenshots and then we have the next question. Take this screenshot for this question. Next screenshot. Next. Next question. Consider the unity feedback control system shown. The value of k that results in a phase margin of the system to be 30 degree. The value of k that results in the phase margin of the system to be 30 degree is what? What is the value of k that results in the phase margin of the system to be 30 degree? Can you answer this? The value of k that results in the phase margin of the system to be 30 degree. Yes guys, can you answer this? No, Anjana, not the correct answer. Please recheck. No, Deepa and Ransom, not exactly correct. Yeah, Yugandhar, correct. Yugandhar SVA, correct. Correct. Very good. Unity feedback system shown below. The value of K that results in a phase margin of 30 degree. Now, given the phase margin, given the phase margin is 30 degree. Okay, no Zishan 60 not correct. Phase margin is given by the formula 180 degree plus angle GJ omega G HJ omega G, that is 30. Okay. Shubham, correct answer. Angle GJ omega G HJ omega G is 30 minus 180, that is minus 150 degree. That is what we can draw the conclusion. Aruna, correct answer. Anjana, now correct answer. Yes. Okay, now phase margin is 30 degree. Now, actually, what is GJ omega HJ omega? What is GJ omega HJ omega? That is equal to K e raised to the power minus J omega is divided by J omega. K e raised to the power minus J omega is divided by J omega. Okay, so what is the magnitude function for this? Magnitude will be K by omega, because I told you e power J theta magnitude is just 1. Okay, and the phase function is actually minus omega minus 90 degree, or I will write it in the form of radian minus pi by 2. Okay, minus omega minus 90 degree, yeah, minus omega minus pi by 2. If you're writing in 90, if you're writing it 90, then remember that this also has to be converted in degree. Okay, so first I will write it as minus omega minus pi by 2, and then you can write it as minus omega, okay, minus omega into 57.3 degree should be equal to minus, sorry, then you can write this as minus 90 degree. Okay, but at omega g, at omega g, the phase is minus 150 degree, as I have derived here. The phase is minus 150 degree. So equate the phase, that is minus omega g into 57.3 degree. Okay, so better to take it in pi, no need to go for 57.3. I'm taking the radian one only. Radian one only. Minus pi by 2 is equal to, directly solve it from here. That is sufficient. That is sufficient. Okay, and this is equal to how much? This is equal to 5 pi by 6. Okay, is equal to minus 5 pi by 6. Okay, so from here first get the omega g. From here first get the omega g, that is 5 pi by 6 minus pi by 2 will be obtained as 2 pi by 6, that is pi by 3. This will come up as pi by 3. This is omega g, but I am interested in calculating the value of k. Okay. Also, now you can use the fact, also at omega g, the magnitude should be 1. The basic definition. This omega g is got from the phase margin formula. But what is the actual formula for phase margin? The magnitude should be equal to 1. So magnitude k by omega g should be equal to 1, which means that k is also equal to omega g, that is pi by 3, and 1.047 will be the answer approximately. Pi by 3. Okay, pi by 3. Now under root of k nahi hoga na Shubham. K is a positive real number. Magnitude of k is just k. There is no root k. 1.047. Correct answer. 1.047 is the answer. Okay. Yes, guys. Screenshot for this case now. Screenshot for this question. No, 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 no. PM is defined in degrees only, Zishan. That is absolutely correct. First, take the screenshot. Answer is 1.047. This is the final screenshot. Phase margin was 30 degree in degree. First, I calculated angle as minus 150. But here the angle expression has e raised to the power j theta term. See, whenever you write e power j theta, the angle is known as theta. But by default, what is the standard unit of angle is radian. And that is why I told if you are solving in degree, convert it into what is 57.3. I told you yesterday also. 57.3 is the conversion from radian to degree. Radian to degree. Or if you are not converting, this is also okay. Or if you are not converting, directly use it in radian. Minus omega minus pi by 2 is minus 150, but minus 150 converted into radian is minus 5 pi by 6. Okay. Degrees, the unit should match. The unit should match. Okay. Yes. So guys, there is a similar question on this. This will be your homework. This will be your homework. There is a similar question. The open loop transfer function is given to you. GS equal to AS plus 1 by S square. Okay. The value of phase to give the phase margin of 45. Similar question. In the previous question also phase margin was given. Given the phase margin. Previous one was gate 17. NAT question 1 mark. Okay. So phase margin was given and we solved. So similarly you can take the phase margin 45 degree and solve. Okay, you'll be able to solve it. So this is your homework. This is another homework for today. Okay, take the screenshot of the homework. Okay. Now next question, guys. Next question. Come to this. It's a common data question 1 and question 2. Come to this question. The Nyquist plot of a stable transfer function GS is shown in the figure. This is the Nyquist plot of GS. We are interested in the stability of closed loop system in the feedback configuration shown. Closed loop system in the feedback configuration shown here. I'll just hide my view. There's also one more figure. This one. Which one of the following statement is true? Okay. GS is an all pass filter. I will just solve this question for you only. See, what is all pass system? I am going to discuss this. And I am going to discuss this somewhere between Bode. Okay, minimum phase, non-minimum phase. There are some things that I will consider that I will explain you separately with Bode. Minimum phase system, non-minimum phase system and all pass system. Okay. No, Zion. No. Okay. Now, GS has a 0 in the RHP. Now, when does GS has a 0 in RHP? I will again repeat the points for you. Even I have discussed, Shubham correct, Aruna correct. Even I have discussed with you in the class number 1 of Nyquist. Even I have repeated in the last class, immediately last class, even the last 2-3 question. Okay. What did I repeat in the last 2-3 questions of today's first class? If 0, 0 is the origin, then what is Z plus? Z plus is number of zeros of GS. Where? In RHP. Okay. And if minus 1 comma 0 is the origin, that our stability analysis. For stability, actually we take minus 1 comma 0 only. And that is the number of zeros of 1 plus GSHS. That is 1 plus GS, unity feedback in RHP. In RHP. Okay, number of zeros of 1 plus GSHS, matlab roots of characteristic equation. So that is related with stability. But option number B is asking you whether the GS has 1 0 in the RHP. Whether the 0 has 1 GS in the option B. So going for option number B. How to check how many zeros of GS in the RHP? Okay, it is given that stable transfer function GS, given GS is stable, given that the GS is stable. Okay, and if the GS is stable, what will be the poles of GS in RHP? Because GS is stable, the poles of GS in RHP will be equal to 0. Okay, so N is equal to P plus minus Z plus, and what is N? What is N? I am looking into encirclement of 0 comma 0 for the given plot. So come back to the diagram. 0 comma 0 matlab actual region. Is it encircled? Is it encircled? Yes, it is encircled once. You can follow my pointer again. Yes, this is encircled once. In what direction? Clockwise direction. It is encircled once in the clockwise direction, clearly seen from the graph. Okay, so from the plot, from the given Nyquist plot, I can say that N is equal to -1. One encirclement clockwise. It is one encirclement in the clockwise. So -1 is equal to P plus is 0 minus Z plus. Solving that, you get Z plus equal to 1. Okay, so option number B is true. There is 1 0 of GS. Z plus means zeros of, this time again, Z plus means 0 of GS, because the origin I have noted the encirclement of 0 comma 0. 0 comma 0. So option number B is correct for the first question. Okay. Correct for the first question. It is definitely not marginally stable. For it to be marginally stable, it should pass through the point -1 comma 0. It should pass through the point -1 comma 0. It is not marginally stable. And what is positive network and impedance all? That is not correct option. That you will learn in the network. I will not go into the network theory right now. Definitely it is not all pass. What is all pass? That I will tell you somewhere tomorrow in the board A classes. It is not all pass definitely. How does the board know Nyquist plot for all put look like? वो भी हम sketch कर लेंगे. But that I will tell you tomorrow. All pass systems. Okay. The gain and phase margin. The gain and phase margin of GS for closed loop stability. Yes, Sai Tarun, were you there in the morning class today? Yeah, exactly, Nihal. Because of checking zeros of GSHS. Option B क्या बोलता है? GS has a zero in RHP. If the zeros of GS are to be taken, 0 comma 0. If the zeros of 1 plus GSHS, characteristic equation, then -1 comma 0. Okay. Now the gain and phase margin for the closed loop stability. From this only you will be able to say the gain and phase margin also. From this only you will be able to say the gain and phase margin also. Let me take it separately. Just a second. इसको हम अलग से ले लेते हैं यहाँ पे. Yeah. Now, the gain and phase margin can be easily described by the given Nyquist plot. Guys, this is what point? This is your point P. This is your point P. So what is the magnitude at P? What is the magnitude at P? 0.5. Minus because it is on the x-axis, negative x-axis. Magnitude is 0.5. So what is the gain margin? 20 log 1 upon magnitude at omega P. So 20 log 2, 6 decibel. 20 log 2, 6 decibel. I will tell you. Yes, Sai Tarun, you first didn't reply whether you were there in the morning class or not. Okay. I'll tell you from my experience that 20 log 2 is now going to be one very common number coming up. So remember 6 dB. Always don't use the calculator for this. 20 log 2 is 6 dB. So gain margin is 6 dB. Okay, gain margin is 6 dB. Okay. What about the phase margin? For phase margin, I need the gain crossover point. The point at which I cut the unit circle. Now, where is my unit circle? Where is my unit circle? Oh, there is a missing data. Guys, there's a missing data here. If there's a missing data here, this is actually given in the question. It is not printed here maybe. It is given in the question. This is point J. It was given in the gate question. I am very much sure that this point was given to be J. Okay. So J matlab it has magnitude 1. So where is my unit circle now? Where is my unit circle now? Because this is J. Unit circle will also pass through J because J magnitude is also 1. This is my unit circle. This is my unit circle. Okay. And the point at which the Nyquist plot cuts the unit circle is actually the gain crossover point. So this is the G. Okay. And what is the phase at this point? If I take the phase clockwise, it is minus 90 degree. Okay. So I will write down here. What is the phase at G? Okay. That means angle GJ omega G, HJ omega G is 90 degree, minus 90 degree because of clockwise. So what is the phase margin? 180 degree plus angle at omega G, plus angle at omega G. So the phase margin is 90 degree. 90 degree. Okay. So option number A. Sorry, option number C. 6 and 90. 6 dB and 90 degree. 6 dB and 90 degree. Option number C is the answer. Okay. 6 decibel and 90 degree is the answer. Correct? Six decibel and 90 degree. Take the screenshot for this. Screenshot for this question. Next one. Next screenshot. Gain margin 6 dB, phase margin 90 degree. Now guys, another question involving this exponential term. E power minus 0.25s. In the GS plane, the Nyquist plot of GS passes through the negative real axis at what point? Yeah, it is sufficiently good. Can be increased, but this is also taken as sufficiently good. Sufficiently good. Because 6 dB means what? Almost you have a margin to double the gain of the system. So that is also good. That is good. Okay, Sishan. The open loop transfer function of a unity feedback system is pi e power minus 2.5s upon s. The Nyquist plot of GS passes through the negative real axis at what point? At what point? At what point? Nyquist plot passes through the negative real axis. Negative real axis matlab the phase is negative real axis पे जिस point पे आप cut करते हो, that is the phase crossover frequency. The first you have to calculate the phase crossover frequency only. What is Gj omega? Pi e raised to the power minus 0.25 j omega is divided by j omega. Pi e raised to the power minus 0.25 j omega divided by j omega. Correct? This is Gj omega. So what is the phase and what is the magnitude? Magnitude function will be pi. E power j theta magnitude is again theta. It is again 1. The magnitude is 1. And what about the phase? Phase minus 0.25 omega minus pi by 2. Because minus the e power j theta, theta is in what? Theta is in radian. So here also I will not write. Here also I will not write 90 degree. Here I am writing pi by 2. ठीक है, तो minus 0.25 omega minus pi by 2. ठीक है. For negative real axis, that is omega p point only, equate the phase as minus 180 degree or minus pi, because I have written the formula in the form of radian. So minus of 0.25 omega minus pi by 2 is equal to minus pi. So 0.25 omega after solving is coming as pi by 2. So omega will be equal to 2 pi. So what is the magnitude? It is given by pi by omega. So that is pi by 2 pi 1 by 2. So magnitude 1 by 2 on the negative real axis. That means what is the point? Point will be minus sign के साथ minus half comma 0. That is option number A. Minus half comma 0. Minus 0.5 comma J0 in the complex form. Option number A. Simple question. Last year GATE 19 1 mark question. Nyquist plot causes to the negative real point. मतलब the phase crossover frequency. Ultimately negative real axis point is related with the phase crossover frequency. Okay, this is the phase crossover frequency only. Okay, next screenshot. Take the screenshot. Okay. Simple one it was for 1 mark. Now next question. Again based on the exponential function. Again based on the exponential function e power minus 2s. Okay. The open loop transfer function of a unity feedback system is given as 3 e power minus 2s by ss plus 2. The gain and phase crossover frequencies are what? And then based on the above results, the gain and phase margins of the systems has to be decided. Okay. Now, I have taken this question, although it's linked question. Linked questions are not there in GATE right now, but they were there in the GATE before 2014. So 2 plus 2, 4 marks. First question, second question is linked on the first. But actually this question I've taken because only one calculation will help you solve all the 4 answers. So what is the Gj omega here? Unity feedback, the only Gs. Gj omega is 3 e raised to the power minus 2s, so minus j2 omega divided by ss plus 2 divided by j omega into j omega plus 2. Okay, just start this question with omega g. सबसे पहले write down gain. सबसे पहले they are asking to calculate the gain crossover frequency. Okay, and at omega equal to omega g, what is the magnitude? Magnitude is 1. Okay, and if the magnitude will be 3, e power j theta magnitude is 1. So exponential term will go away whenever you are taking the magnitude. Divided by omega root over omega square plus 2 square, that is 4, and इसको equate करना है 1 से. Okay, so I have 3 is equal to omega root over omega square plus 4, correct? So squaring it, 9 is equal to omega square plus 4. Okay, and to solve this equation, first of all put down omega square equal to x. Putting omega square equal to x, you get 9 equal to x into x plus 4, or you get the quadratic equation x square plus 4x minus 9 equal to 0. X will be equal to minus 4 plus minus root over b square, that is 16, minus 4ac, so minus 4ac, minus 4 into minus 9 plus 36 divided by 2a. So x is minus 4 plus minus root over 52 by 2. But x is omega square and it should be positive. Square should be positive, otherwise you will get non-real frequency. So what is the omega square that I can take? What is the omega square that I can take? Only one of the solution is required. Take omega square equal to minus 4 plus root 52 divided by 2 plus wala, or minus 4 plus root 52 is 4 into 13, so that will be under root of 4, 2 root 13 divided by 2. So omega square is first of all minus 2 plus root 13. Let us calculate this value. This is coming up as 1.6. So omega g is under root of this number, and that is coming up as 1.26 radian per second. Now, in this case, yes, negative wala liya hi nahi because otherwise omega will be negative. Omega is 1.26, and if you are able to see, only one of the option matches where omega g is 1.26, so omega p need not be calculated, and neither you will be able to actually calculate omega p. This can only be done by options. This can only be done by option because you will get an equation in the form of one is tan inverse term and one is omega term. That is not solvable. Okay, but need not calculate. I'm telling you, sometimes MCQ questions only one calculation will be able to mark the option. So with this, I will be able to mark option number D. Okay. Now, according to the option number D, omega g is 1.26 that we have calculated, and what is omega p is 0.632. Correct, na? 0.632. That means here omega p is less than omega g. Omega p is less than omega g. Okay. Or omega g is greater than omega p. I have told you one conclusion. Omega g greater than omega p. What is the conclusion about stability of the system? Omega g greater than omega p. What is the conclusion about the stability of the system? That is unstable. I've told you in the beginning of the class those key pointers. It is unstable. Omega g coming later, it is unstable, right? D pi, it is unstable. Okay. And if it is unstable, guys, if it is unstable, both the gain margin and phase margin should be negative. Okay. So question number 2 also, you get the answer directly. I'll hide my view. Both should be negative. See, anyways, first of all, this is scratched. This is scratched. This is never possible, I told. One positive, one negative, it is not possible. Okay. Stable system hota to option B, unstable hai to option D. Both are of opposite sign. Option number D is correct. Question number 2 maybe aa jayega. Option number D correct. So see, sometimes only one calculation will be able to solve multiple questions. Matlab 2 questions are just solved if it is MCQ. Okay, and because it's a gate question, I've talked about the approach which is based on the MCQ question. Not all calculations are required. Just one calculation can make you solve the total 4 marker. The total 4 marks can be achieved by just omega g calculation. All right. Understood this? A and C are never possible. They cannot be of the opposite sign. They cannot be of the opposite sign. That is why I strike A and C. Okay. All right, take the screenshot for this. Take the screenshot for this. Yes, I hope you are able to solve. I am taking all variety, gain margin, phase margin. Itna variety kar liya, so then you are much comfortable with gain margin, phase margin. It's just not like I started a topic and ended. Trying to cover all variety of questions, all concepts related with gain margin, phase margin. Beginning, we have taken several special cases also. Okay, where to apply the formula, where to take the precaution. Next screenshot. Just one calculation in this question sufficient to solve all the 2 questions and all the 4 calculations. Next screenshot. And now another question. For a unity negative feedback system, obviously take it as negative feedback, not specified also, but take it as negative feedback. Gs equal to 10 e power minus st by s 1 plus 0.1 s. Determine the range of t for the system to be stable. Now this has a good concept. This question has a good concept, understand, for the range to be stable. So see, if I talk about the characteristic equation, guys, understand it is 10 e power minus st divided by s 1 plus 0.1 s. Okay, and expanding you get 0.1 s square plus s plus 10 e power minus st equal to 0. Okay. Now, should I apply the RH criterion here? We have solved some questions by RH on the range of this for the system to be stable. Should I apply RH? What is one of the limitation of RH? I told you RH to be applied whenever it is a polynomial equation. Okay. It is not a polynomial equation. Okay. It is not a polynomial equation. Polynomial means only powers of s square, s cube, s power 4. So it is not a polynomial equation because of the term e raised to the power minus st coming up. ठीक है. So RH, ठीक है. RH, even if you try to apply RH, you can be able to apply on an approximate basis. On an approximate basis, you will write down 0.1 s square plus s plus 10. Let's take e power minus st by the Taylor form. 1 minus st plus s square t square by 2. See, why this is very much approximate? Because actually e raised to the power minus st has infinite number of terms. Okay, but I am only taking the second order approximation of this. I am taking the second order approximation of this by the Taylor's expansion. Okay. Second order approximation, quadratic approximation. Okay. Now, if it is a second order approximation, you can now go and apply RH. Okay. But RH gives, okay, RH is not perfectly applicable because of this approximation. RH not perfectly applicable. Why? Because of this approximation, second order approximation. And obviously e power minus st by Taylor's has infinite terms, and you can't solve by infinite terms also. You cannot solve by infinite terms also. Okay. Okay. So, stability analysis of such cases can be done by the concept of gain margin and the phase margin. Can be done by the concept of gain margin and the phase margin. Okay, so let us start by the concept of phase margin, because the e power minus st term, phase margin के लिए सबसे पहले आप क्या निकालेंगे? ओमेगा जी. ठीक है. E power minus st term, let me first write down what is gj omega hj omega. What is gj omega hj omega is 10 e raised to the power minus st minus j omega t divided by j omega 1 plus 0.1 j omega 1 plus 0.1 s. Okay. The e power minus j omega t term, when you take the mod, its magnitude is 1. Okay, but its angle is minus omega t. Angle of e power minus j omega t is taken as minus omega t in the form of radian. I've told you 100 times now. E power j theta mein theta is in the form of radian, the Euler form. So, rather than going for gain margin, better you see that the mod of this term is 1. So, it does not have the effect on magnitude, but it has a lot of effect on the phase. It has a lot of effect on the phase. So, let's start with the phase margin. Let's start with the phase margin. Starting with the phase margin. And for phase margin, I need omega g first. Okay. So, what is omega g? At omega equal to omega g, the magnitude is 1. So, take down the magnitude. That will be 10 e power j theta magnitude is 1 divided by j omega magnitude is omega under root of 1 plus 0.1 to 0.01 omega square equal to 1. Let us try to solve this. Okay, so 10, even let's square it. 10 square equal to omega square 1 plus 0.01 omega square. As always in the omega g problem, always you are getting omega square term. So, same calculations repeated. Put down omega square equal to x. Put down omega square equal to x. Okay, so I get 10 square, that is 100, equal to x 1 plus 0.01 x. Okay, or 0.01 x square plus x minus 100 equal to 0. Okay, so let me quickly give you the solutions right now. We can solve it by the formula as well. Let me quickly give it to you. What are the values of x coming? X, which is omega square, one of them is coming as 61.8, other one is coming as minus 161.8. Okay, minus 161.8. One is 61.8, one is minus 161.8. Obviously, choose the positive one, discard the negative one because square cannot be negative. Okay, so I take omega g square as 61.8. So what is omega g? Under root of this term. So I am getting omega g as correct, Deepa. It is 7.86 radian per second. Okay, Ria, it's not 1. Please recheck. The omega g is 7.86. Omega g is 7.86. Okay. Now, why do we calculate omega g to come to the phase margin? Okay. So now let us define the phase margin. Phase margin is 180 degree plus angle gj omega g hj omega g. Okay, that is equal to 180 degree plus what is angle gj omega g hj omega g. From this you can take down the angle. 10 is positive real number, angle is 0. E power j theta angle is theta minus omega t. Okay, then denominator ke liye minus j omega phase. J omega is now, because this is 180, phase margin is calculated in the form of degrees only. Standard unit of phase margin is degree. So this is radian. I will convert it into degree. Wait on. Let it be minus omega t. Then I have minus 90. And then I have minus tan inverse 0.1 omega. Tan inverse y by x. Okay. So actually the phase margin should be equal to 180 minus 90 is 90 minus omega t into 57.3 degree minus tan inverse 0.1. Put down omega equal to omega g. Okay. Put down omega equal to omega g. So here I will put down omega equal to omega g minus tan inverse 0.1 into 7.86. The value of omega g obtained 7.86. Okay. Let us see what are the calculations. 180 minus 90 already 90 likh diya, and 90 minus 0.1 omega g. 0.1 omega g. This is coming up as, phase margin is coming up as 51.83 degrees minus omega d into 57.3 degree. Okay. Now what is the range for stability? What is the range of T for stability? Yahi question tha na? So I will write down the answers now. For stability, what is the required phase margin? It should be positive. So 51.83 minus omega t into 57.3 should be greater than 0. So omega t into 57. Now omega means what? This also omega should be replaced by omega g. This also to be replaced by omega g. So let me replace it better. I will better replace it here only. So this is omega replaced by omega g 7.86 t into 57.3 into 57.3. So this omega was 7.86 t into 57.3 less than 51.83. Let us solve from here. So 51.83 divided by 57.3 also divided by 7.86. I am getting the answer as t less than 0.115. T less than 0.155. Yahi question tha na, what is the range of T for stability? Yeah, Neha, 0.114, 115 approximately, both correct. Okay, so that is your final answer. Question was range of T for stability, range of T for the system to be stable, and I've used the concept of phase margin to solve this question. Okay, T less than 0.115. Maybe Raut-Hurwitz is applicable, but approximately it does not give the perfect answer. Okay. Why? Because exponential is not a polynomial function. You are approximating the exponential to polynomial function by Taylor's. How many terms to consider for Taylor? That we can't say. I took only second order because the starting term was second order to keep it as a second order system. But actually, it's not perfectly applicable. The actual analysis using the exponential term for stability is done using the concept of phase margin. All right. Screenshot. ये कोई गेट का और ईएस का क्वेश्चन नहीं है, बट जस्ट आई टुक इट एज अ क्वेश्चन. इट्स अ वेरी गुड क्वेश्चन टू अंडरस्टैंड द कॉन्सेप्ट ऑफ एक्सपोनेंशियल फंक्शन, हाउ टू रिलेट द स्टेबिलिटी विद द फेस मार्जिन. So concept wise this question is important for understanding. Next question, sorry, next screenshot. Next one. Next one. Next. Okay. Chaliye guys, that's it for today's class. It's 4:30. We'll close today, and then next class, that is tomorrow, Sunday, at 10 a.m. Fresh day, fresh morning. We have the Bode plots discussion tomorrow, and then at 2 p.m. Bode plots class number 2, 5 p.m. Bode plots class number 3. So tomorrow it is totally about Bode plots discussion. All classes are Bode plots tomorrow. Bode plots class number 1, 2 and 3. So tomorrow it's the complete day for Bode plots. Okay. Now Bode plots is with respect to MCQ questions, with respect to GATE or ESC prelims. Bode plot is as equally important as Nyquist. मैंने बोला था, sometimes there may be question from Nyquist, sometimes from Bode, sometimes from both of them. But Bode questions are relatively much more simpler. Okay. Sketching of Bode plot is also much more simpler. Analyzing the Bode plot question is also much more simpler. Okay. And it is very expected commonly as a 2-marker question. Some questions are very simple on the conclusion of Bode, they are 1 marker. So what is the variety of question? That all we learn, but first we'll understand Bode plot. So tomorrow first class, let's start with the Bode plots and understanding Bode plots. Bye bye, take care, see you tomorrow, give your feedback to the class. Okay, and this was till now all the Nyquist plots, and relating to the Nyquist plot we have understood the gain and phase margin, and we have solved separate questions on gain and phase margin. So I hope the concept, very important concept of gain and phase margin should be there in your brains right now. If you want, you can revise your lectures, the videos are available, screenshots आप लेते ही रहते हैं, so do keep revising. These are important, means very important questions. Okay, so I will stop the stream now. See you tomorrow at 10 a.m. with Bode plots. Take a very important topic again coming up.